Okay, so now we're going to start section 5.3. What we're going to do in this section now is kind of go backwards. We're going to be given the z-score, and we need to find the area associated with that z-score. So let's get started. Remember in section 5.2 we were given an x value, right? And then from there we went to the z-score and then found the probability. Now we're going to be given the probability. We're going to find the z-score using the table, the standard normal table, and then modify the z-score formula to find the x value. So let's start off. Let's find the z-score that corresponds to a cumulative area of 0.3632. Now recall, cumulative area means it's the area shaded to the left. So we know we're looking at a negative z-score, right? Because it should be, if it's less than 0.5, it's going to be to the left of the 0, which are the negative numbers. So we're going to get the table out, look on the side with the negative values, look through the body of the table until we find 0.3632, which is right there. And then we read the z-score that is associated with that, which is negative 0.35. Negative 0.35. So the z-score is negative 0.35. Let's do the same thing now, but this time let's find the z-score that has 10.75% shaded to its right. Now, that's the picture of 0.1075, 10.75% written as a decimal, shaded to the right. But recall that our standard normal table always has the cumulative area. So we need to find how much is here. Well, if the whole thing is 1, then what's over here is 1 minus 0.1075, 0.8925. So now we're going to, that's the cumulative area associated with that z-score. Let's get the standard normal table out and look for 0.8925. There it is. Then we read the z-score that associated with it, 1.24. So the z-score is 1.24. Let's find the z-score that corresponds to P5, which is the notation for percentile 5, which means we're talking about 5% shaded in the bottom. Percentile 5 is a value such that 5% of the values are less than it. So here's 5% less than. We get out our table and we look and we see that we don't see a 0.05, we see a 0.0495 and a 0.0505. Now, 0.05 is exactly halfway between these two values. So halfway between negative 1.64 and negative 1.65 is negative 1.645. Now, once we have the z-score, we can use our z-score, which is z is equal to value minus mean divided by standard deviation. If you take this algebraically and solve for x value, and we get this formula. Now that we know the z-score, we can find the x value associated with that z-score. So, for example, suppose we have the weights of cats, and we know that these weights correspond to z-scores of 1.96, negative 0.44, and 0. We use this formula, plug in the mean being 9, standard deviation being 2, and then these respective z-scores. And we get for 1.96, 9 plus 1.96 times 2 is 12.92. So you have negative 0.44, 9 plus negative 0.44 times 2, which is 8.12. And a z-score of 0 is the mean, because it's 0 standard deviations from the mean, so it must be the mean. But look, if you plug it into the formula, we still get the 9. Let's find a specific data value. Suppose that the California Peace Officer Standards, they want only the top 10%. So what's the lowest score we can get in order to be eligible for the top 10%? Well, if we do the top 10% means 90% is in the cumulative area. We go to the z standard normal table. We look up 0.90. And we see that the closest score is 1.28. So then the z-score is 1.28. So now let's find the X that is associated with that. The mean was 50, the standard deviation was 10, the z-score was 1.28. So you have to get at least a score of about 63 to be accepted into this program. So that's the end of section 5.3. Now go to the My Math Lab website and do the homework set for 5.3.